In this tutorial we're going to be looking at log scales. Now log scales are used in a lot of our scientific uses and situations. And there's things like our loudness of sound, which we measure in decibels, or the magnitude of earthquakes, which is measured by the Richter scale, or our octaves in music, our pH scale, or the intensity of the brightness of stars. They all use log scales. So basically this section is very much going to be on applications. So we've got one worked example that we can have a look at, which is talking about the loudness in decibels of sound, and we're told that the loudness is equal to 10 times log to the base 10 of our intensity I over I naught, where I naught is equal to 10 to the negative 12 watts per metre squared, and that's the lowest level of sound that we can hear. So that's this value here. What we wanted to find out is what's the intensity in watts per metre squared when we have a loudness value of 60 decibels. So what we need to do is put our 60 into our equation, so that we've got 60 equals 10 log to the base 10 of I over I naught. Well, we can divide by our 10, make it 6, because log to the base 10 of I over, and we know our I naught is 10 to the negative 12. So we can make that 10 to the 12 times I. And now we can do our looping method and say that we've got 10 to the power 6 equals 10 to the 12 I, and go 10 to the 6 over 10 to the 12 will give us our intensity. We can subtract our power, so we get our intensity equals 10 to the negative 6 watts per metre squared. And we also want, if the intensity is doubled, what is the change in the loudness corrected 2 decimal places? So if we double our intensity, what is the change in our loudness? So what we're saying is we're going to go, say, well, L equals 10 log to the base 10 of 2 times our intensity over I naught. Is what we're going to go there. Now again, we can put in our value for I naught to I over 10 to the negative 12, which we can write as 2 times our 10 to the negative 12 times, 10 to the positive 12 now, I. So what we're going to do here is we can actually split this up now and say that we've got 10 log to the base 10 of 2, plus 10 log to the base 10 of our 10 to the 12, plus 10 log to the 10 of our I. So all I've done there is split these up, because these are all times. So from our log laws, we're allowed to split up into a series of addition. And we do that because we find 10 log to the base 10 of 2 is 3.010. We work it out on our calculator. Plus, well, we can bring our 12 down the front to make that 120 log to the base 10 of 10, plus our 10 log to the base 10 of I. So you can say, well, that's our 3.010, plus log to the base 10 of 10 is 1, so that's our 120, plus our 10 log to the base 10 of I. So we're getting there now. So what we know is this bit here, is really, our original loudness, this bit here. It's our original loudness, so really we've got 3.010 okay, plus our original loudness. Okay, so if we double the intensity of our loudness, okay, we're going to increase by 3.01 decibels. Okay, so this is our original part of our loudness there. Okay, and so that's all we've actually got for this section. So as I said, they're all going to be our application type questions for this section.